The graphic shows a footbridge near Liverpool which is based on a hyperbolic paraboloid. The projections of the bridge are given in figure C2 below. Okay. The elements of hyperbolic paraboloid surface A, B, C, D are extended outwards to form the curved outline loop of the supporting steel structure. Draw the given plan elevation of the hyperbolic paraboloid A, B, C, D using a number of elements shown and include the projections of the walkway. Okay, so we're looking at setting up our hyperbolic paraboloid here. Here, okay, so it's our lines here, So we're going to start by setting this up here. Scale 1's key now here. Scale is 1:500, so that will catch us out. So we just need to divide all our measurements there. So that's 32 meters. So if I'm going to say 32 meters is 320,000 millimeters. Divide them by 5. 5 into 32 goes. I can calculate out here now the way on these. So 32000. Yes, that's 32,000 millimeters. Divide that by 500, so that's 64 there. Okay, so it's 64 mil. Okay, so we just need to be very careful splitting them up. 64. Ah yeah, so if you take that and double it, that's what I'm going to do there now. Okay, I am going to keep it over towards the left hand side of the page. I'm going to project an end view possibly over to the thing. So I'm going to set up my XY line. .5, so that's up 15. Across, up 64. Okay, so it's 160 in length. Up 32 here, give me that line there. So that point there, that point there, and this point here is my top. That's A, B, D, C. Down to my plan here then. Must be 90 wide. Are you down here? B, C, D, A, B, C, D. Join these up here now, broken lines. Right, so we need to draw these elements here now. Okay, so these elements here are used for creating our hyperbolic parabola here, which is basically that sloping surface. It slopes in there, and it's sloping in there, and it's sloping that way. Okay, so you can see in the image up here, it's falling in that way, and it's falling in that way. Now, these elements here, we need to find these, okay? So, we have this one, this one, this one, and this one. Okay, if we go parallel to them through the center, it'll help give us more of them here. So we're looking for this point here and this point here. So we have this and we have this. So these then are just divisions of this distance here. So if we divide up this line into, what is it? 1, 2, 3, 4 sections. So I'm going to come down here and do my division and line construction. 20, 40, 60, 80. Okay. Join this back here. That'll give us all little divisions there. Okay. Now we can take those divisions and step them out here then. We can go back the other way again the same way. Okay. Where this guy and this guy cross, that gives us the width of our roadway. Okay, draw the given plan elevation of the hyperbolic paraboloid A, B, C, D using the number of elements shown and include the projections of the walkway. So that's the hyperbolic paraboloid there. It's a sloping surface that way. And we can just draw it in up here then in our elevation. So So that's the projections there of my hyperbolic paraboloid. Okay. So that's the projections of it. Elevation and plan, A, B, C, D. A, B, D, and C. Okay, part B here then is the curve A, B, C. A, B, C is a parabola in elevation with a vertex of B. Draw the elevation of this parabola. Okay, so ABC is a parabola with the vertex at B. So what we have to do there now is we have to draw our parabola. So how do we do that? Same way as we would normally. We just divide up our sections into, I'll divide it up into 4 because that's what it's divided up into down the bottom. And same up the top then. It's actually 80 wide, so we can actually just go 20, 40, 60, 80. That's one of the only times we'll ever be able to do that now is because very rarely does it actually line up with using a regular measurement. So I'm just going to throw them down there. Again, 90 degrees to the vertex, joins back to the vertex, opposite the vertex, goes parallel with the axis. Okay, draw the elevation of this parabola. Yep, there's the elevation going up. We can probably drain these guys now, so 24 mil from the edge of the next Y line. Going to go as far as there for the moment. They'll be extended up afterwards. Right, so part C of the question here is project from the elevation the given plan of the curved outline loop and project an end view. Draw the walkway in the end view. Okay. So what do we have? We got our parabola up here. We got our hyperbolic paraboloid here, okay? We have it here in end view and we have these elements. What I need to do is I need to find these elements. Right, what I'm going to do here is I'm going to take this green element here and make this line green here. Okay. Where does that cut AD? So I'm going to bring that up here to cut AD up here. And I'm going to bring it up here to cut BC up here. Okay. I'm going to extend that through there and there till it hits my curve. Okay. So that green line there in plan is my green line in elevation. Now, where that then hits my curve, that hits my curve there, I can drop that down onto my green line in plan there. That's going to be here if I extend it out. There and there. Okay. That's the green line there extended. And it's the same then with the other side. Now you can do this. I'm going to take that green there, drop it down. And that's where the green line is extended out to there. So that green line in elevation is the same as the green line in plan. What that does is that gives me this point and this point, which is the same as here, like, so that point there. So I can take that point across even the other side, because I'm just going to work on half the curve. Take across to there, drop it down, and it's going to be here and here. So extend out that green line there, and extend it out there. So there's another 2 points. Okay. Last thing I need to do is I just need to do the same then with this one here. So I'm going to bring this one up to hit my hyperbola. It's in the middle there. It comes across, bring it down there and there. And there's all my points. Okay. What you can do with them then is you can just take your compass and take the distance from one side to the other and step them off. It's probably easier than having to transfer them all across. It's probably easier than, you can redraw them all if you want, but it's probably easier just to take a compass and just step it off. So I actually have it there. And it's down underneath it here somewhere. Extend that one down. There it is. And there's all my pints then. Train it up. Okay. And wants us to project an end view and include the walkway in the end view. Well, what we'll do then for an end view there is just finish off this elevation up here. The elevation is, for example, that point there is vertical to this one. So if I bring these up here, where this cuts my plan there, so it's that generator there giving me that, draw that out, and I can extend this up here. Okay, now what we need to do is project up an end view from here. So all we need to do is project all our points from our base here, bring them across to this edge, because this is where we're going to project from. Here we can bring them up in numerous ways. You can draw a line out 45 degrees there, draw them across, bring them up, rotate them around, or what I'm doing is I do it at 45 degrees. I just use my 45 degree set square and bring them up. Okay, and that's my center line there then. Okay, and all I have to do then is match up points here with the generators above it. So for argument's sake, I'm going to just draw these up quickly. Okay, so that's D there. So DD. Now, this is my first one here. So there and there. My second generator here. This mine up here. It's there. It's that center line. So it's there and there. My third one is here. It's on this line, yeah. So the fourth one in. Fourth one in. The fifth one is my roadway and my center line. Okay. And that's my D, B, A, C, and I'm going to project the roadway up there then. So this is my roadway here. So that's going to come across. And it is these lines up here. This is my roadway inside there. Okay, so that's the road inside in the middle of the bridge there. Okay, draw the walkway in the end of it. There it is, perfect. So we have, yeah, that's it, done then. Part D of the question then says the line CE. CE. E is here, yeah. Is a normal to the parabola at point C. Okay, yeah. Determine the focal point and the directrix of this parabola in elevation. Okay. This is a little bit of comics here now. So what we need to know is we need to know the principles of tangents and ellipses. Okay, so if we look down here, if I have an ellipse here, I have focal point, I have a point on the curve. If I want to get a tangent to that, I join from one focal point through the point, through the other point, bisect the angle, I get my tangent. Perpendicular to my tangent gives me my normal. Correct? A parabola, if I have my axis there, I have my directrix, I have my vertex, I have my focal point. My line of eccentricity is at 45 degrees, we know that. Okay, because a parabola is 1:1. Okay, so the distance here to here is the same. Okay, I have a point here, I have my focal point. If I want to draw a tangent to a parabola, I have to join focus point through this ellipse, or through the point. I have to join to the other focal point. Where is the other focal point? It's out here somewhere. A parabola is going to continue on forever, so what it means, the further it goes out, the further it goes out, the further it goes out. That means my line is going to, my focus point is going to be out at infinity, which is at parallel to the axis. So I draw a line parallel out to the axis, okay? Then I get my angle there, I can bisect that, I get my tangent, and I get my normal. Okay? With that piece of information now, pause the video and go try answer this. Okay? If you want to have a look at that, go back over that again there and pause it or ask me any questions before you have a go at it. Okay? I'm going to go through it here now. So, I know that that's my normal. So if I go perpendicular to that, through C, I get a tangent. Okay? If I bisect that angle, sorry, no, but I got it right there. I just want to make sure I put it in the right place. There. There. I'm trying to double check now, just want to make sure. If I have my normal and I have my tangent, focus point through, bisect the two focus points. So it's not the distance between. Sorry, I have to double over my angle. So this is the normal here. And this is my normal here. This point is heading to my focal point out in infinity. Okay? So this angle here is the same as my angle on the other side back to my focal. Okay, I got that mixed up a little bit there now. So I'm going to measure this angle here, which is 52 degrees. Sorry, no, 57 degrees. So if I come up here then, mark 57 degrees, join that back there to where it cuts my axis, gives me my focal point. Okay, and because I know then that it's a parabola, the distance from the vertex to the focal is the same as the distance from the focus to the vertex, or to the directrix. From the vertex to the directrix, which is then perpendicular to the axis. Okay, and that's that question done. It's not too bad, just takes a little bit of understanding. I got a little bit, I confused myself there at one point, but when you have a think about it and just get it worked out, the angle between the tangent, or between the normal and the focus here, must be the same as the angle between the tangent and the focus on that side.